Welcome back to the OBIS Controlled Vocabulary series. In this video, we will follow the P01 decision tree for a few example physical measurements. If you're not familiar with this decision tree, please see the first video in this series. The first example we will look at is simply the water temperature at sea. So moving along our decision tree, the first question is, which identifier are we looking for? This is of course the measurement type ID, not the measurement value ID or the measurement unit ID. Next, what type of measurement do we have? Well, we are looking at physical measurements in this video, so we will go along the purple branch to the physical or abiotic measurements. The first action we see is of course to navigate to the CDataNet facet search, which we already have open. Next, what is the measurement property, and is it a statistically derived parameter? The action box tells us to search for the measurement, but to be careful not to apply too many filters, as the search results may become too narrow. We discussed overfiltering in the biological measurement video. So to answer these two questions, the measurement property is the temperature, and in this case it is not a statistically derived parameter. So let's search for temperature in the free search box. Now there are 324 results, but just taking a quick look, we can see that the results include measurements not directly related to temperature. So we will go ahead and select temperature from the measurement property box, which has now filtered our results down to 142. Next question is, what is the physical entity being measured? Is it the environmental matrix or another physical entity? The measurement is the temperature of the water, which is the environmental matrix. We can see the reminder off to the side here to ensure you are thinking about whether there are subgroups or subphases related to the matrix. But moving along the decision tree, we know that the physical entity is in fact the environmental matrix. So what's the measurement matrix relationship? It's simply of the. So under matrices here, we can select water body. So the measurement matrix relationship, we can narrow down a little bit farther using of the. And the action box here is reminding us to consider the units of our measurements, whether a subgroup was targeted, and this information can help us determine the matrix and the measurement matrix relationship. This measurement type is relatively simple, so we know that the matrix is a water body. The next action is to check the search results for appropriate P01 codes while carefully considering all methods used to obtain the measurement. So related to this is the question, were any methods used to obtain the measurement? In this case, we don't have that information, so we will need to make sure we select a P01 code that is general enough and does not include a method. So let's start looking through the search results. The second one here is the temperature of the water body by in situ thermometer, which is including a measurement. We want to make sure we select a P01 code that does not have a method. Let's move to the next page. And right away we can see this P01 code, temperature of the water body. It does not include any methods. So let's check the definition and obtain the URI. So the definition is the degree of hotness of the water column expressed against a standard scale, and it includes both IPTS 68 and ITS 90 scales. This definition is general enough that we can copy the URI into the measurement type ID field for records documenting the water temperature. For our second example, we will find a P01 code for the standard deviation of salinity in the water, which was obtained using a salinometer. So moving down our decision tree, we have already navigated to the CDataNet facet search. What is the measurement property, and is it statistically derived? The measurement property is the salinity, and it is statistically derived. Let's search for salinity. Now, we could select a salinity from the measurement property box. However, we can see that there are a number of different types of salinity, so let's skip that step to avoid overfiltering. Instead, let's scroll down to the measurement statistical qualifier, and we will select standard deviation. A reminder that if you do not see the desired qualifiers, please do not select a P01 code excluding these, as we want to make sure the P01 code best suits your data. We cover how to approach these situations in the final video of this series. Now, moving along our decision tree, the next question is, what is the physical entity being measured? On this case, again, it is the environmental matrix because it is the water column. So we can go ahead and select water body. And the next question would be, what's the measurement matrix relationship? However, we only have 5 results left. So before going through more questions and perhaps overfiltering, let's review our results and see if we can find a match. Each of these 5 measurement types have to do with the practical salinity standard deviation of the water body, so that's good. However, we want to select the one that has used a salinometer, which it is only the second one. Let's click the concept ID to learn more about this P01 code. The definition here relates largely to the standard deviation, which may not be the most informative for us. However, if we wanted to confirm elements of this definition, we can of course look through the elements here. For example, if we wanted to confirm that a bench salinometer, we can simply click the link to its left. So the NERC vocabulary server has defined a bench salinometer as a laboratory instrument for precise, accurate determination of salinity by relative conductivity measurement with certified standard seawater. That's a pretty thorough definition. However, it matches the methods for our measurement of using a salinometer. So we can go back and select the URI for that measurement type. So we'll go ahead and copy this and place it in the measurement type ID field. For our last example, we will find a P01 code for the depth determined by an echo sounder. So jumping right in at what is the measurement property and is it statistically derived? Well, no, it's not statistically derived, and the measurement property is the depth. So we will search for depth. The next question is, what is the physical entity being measured? Is it the environmental matrix or physical entity? Well, we're looking at depth, so the physical entity being measured is the environmental matrix, the water body. So for matrices, we can go ahead and select water body. Similar to the previous examples, the measurement matrix relationship will be of the, so we can go ahead and apply that. This has narrowed our results down to 18. And the next action says to check the search results for appropriate P01 codes while carefully considering all methods used to obtain. With the related question, were any methods used to obtain the measurement? Well, we know that an echo sounder was used, so to filter this down in the free search, we can search for echo sounder. Now we see that there are only 5 results, all of which have to do with the seafloor depth. However, each of these have elements that are not relevant to our measurement type. This one uses a correction. This one is the 10-minute mean, as well as other methodologies. Then there's an hourly mean, a 30-minute rolling mean, and an hourly rolling mean, as well as various additional methodologies. So we have clearly encountered some overfiltering. So let's try to resolve this by removing some of our filters. Let's start with of the. Now we're back up to 18 results. Now we simply want the depth measured by an echo sounder. So we can see the first one is an echo sounder and a correction. The first several uses corrections. Now we've reached the 8th result, which is the seafloor depth below unspecified datum of the bathymetric depth in the water body by an echo sounder. It has the right methods. However, this below unspecified datum implies that the depth was taken at a specific point. However, that was unspecified, and this is not the case. So let's keep looking. Now we have this one, which is seafloor depth below instantaneous sea level, the bathymetric depth, in the water body by an echo sounder. Below instantaneous sea level simply means below the sea level at that specific moment in time. It does not refer to a different reference point. The reference point is sea level. Let's click the concept ID. Unfortunately, the definition is unavailable, so we cannot contrast that. However, we do know, given the title of this P01 code, that it is general enough to suit the measurement type depth determined by an echo sounder. So we can go ahead and copy this URI and place it into the measurement type ID field for records associated with this measurement. You can see that sometimes it can be difficult to determine which exact P01 code best suits your data. That's why the OBIS vocabulary team is here to help, and we are happy to answer questions. You can submit vocabulary questions to the OBIS vocabulary GitHub repository by clicking New Issue. Of course, you can also contact us on Slack. In the next and final video in this series, we will go over details on what to do when you cannot find a suitable P01 code.